Hey everyone, and welcome. Have you ever felt like you're just constantly fighting to squeeze every last drop of performance out of your database? Well, if that sounds familiar, you are in exactly the right place. Today, we're going to pull back the curtain on the Automated Designer, a seriously powerful tool that helps take all the guesswork out of optimization. Let's jump right in.
So, tell me if this rings a bell. You've got reports that used to pop up in seconds, but now you have time to go grab a coffee while they run. Your app's load times are just creeping up, and you're starting to hear about it from your users. You know you've tweaked the queries, you've thrown more hardware at it, but it just feels like you're running in place.
You know, the big secret to lightning-fast analytics often has less to do with the queries themselves and everything to do with the physical design of the database. I'm talking about how your data is actually stored, how it's sorted, and how it's laid out on the disk. That is what makes or breaks performance. But as you probably know, getting that design just right is a notoriously difficult balancing act.
Yeah, pretty much every database team on the planet runs into this fundamental conflict when they're working on physical design. It's this constant tug-of-war between three competing goals, something we call the iron triangle.
And this right here shows you exactly what I mean. Of course, you want blazing fast query speed, right? But that usually means creating lots of specialized sorted copies of your data. The problem is that slows down your data loading because every new row has to be written to all those different places. And naturally, it makes your storage footprint swell up. So if you optimize for one corner of the triangle, you almost always end up paying the price in the other two.
So how in the world do you solve this puzzle? Well, allow me to introduce the hero of our story today, the Database Designer, or DBD for short. Think of it like an expert consultant that lives inside your database. It looks at your table structures, it analyzes your actual data, and it even watches the queries you're running. And then it does the heavy lifting of balancing that iron triangle for you and proposes an optimal physical design.
And you know, its power goes way beyond just speed. For anyone who needs high availability, setting up case safety can mean a whole lot of tedious manual scripting to make sure you have data duplicates. Well, the DBD just handles that automatically. It creates these things called buddy projections to make sure your database can easily survive a node failure, all with zero extra effort from you. Pretty neat, right?
Now, the Database Designer isn't just some simple on or off switch. It's a pretty sophisticated tool, and it gives you two very distinct strategies to work with. Because let's face it, optimization is definitely not a one-size-fits-all kind of problem. Let's take a look at what they are.
So the two main flavors here are comprehensive and incremental. The names kind of give it away. A comprehensive design creates a complete replacement for your current setup. It basically reimagines everything from the ground up. Incremental mode, on the other hand, is additive. It keeps what you already have and just builds new, targeted optimizations on top of it.
Okay, so when would you go for the total makeover approach? Well, a comprehensive design is absolutely perfect when you're setting up a database for the very first time, or maybe after you've made some massive changes to your schema. It's also super important if your data has just grown like crazy. We're talking going from a gigabyte to 10 terabytes, because all the old assumptions you made about your design are probably totally out the window.
And what about that more targeted surgical strike approach? An incremental design is your best friend for specific fixes. Say you've got this one report that's become a huge bottleneck. Or maybe you just added a new table and you need to optimize it without messing with the rest of the system. In that case, you just feed the designer that one problem query, and it will build a brand new projection just to solve that single issue.
All right, this all sounds fantastic in theory, but how you actually use this thing? Let's walk through the two main ways you can get the Database Designer to do its magic.
For most of us, the journey is going to start right in the Management Console's Visual Wizard. It's a really straightforward, step-by-step process. You pick your tables, you upload a file with a few typical queries, you set your high availability level, and then, and this is my favorite part, you get this awesome graph that compares the performance of your current design versus the one it's proposing. You see the benefit before you commit, and once you like what you see, you just click deploy.
But what if you need to automate all of this? Or maybe integrate it into a bigger workflow? Well, for all you power users and DevOps folks up there, don't worry. There's a whole suite of command line and programmatic options. Yeah, you can call the designer right from the command line. With admin tools, you can use a text-based interface, or you can even kick it off using SQL functions directly in your code. This is incredibly powerful for automation. It means you can build database optimization right into your CI/CD pipelines. So, we've seen how powerful this tool is, but I have to be really clear about this next part. Automation is a fantastic assistant, but it is not an autocrat. The single most important step in this entire process is taking the time to review the output before you deploy anything.
I really want this to sink in. Maybe even write it on a sticky note. Just repeat after me. Never deploy blindly. Look, the designer is brilliant. It really is. But at the end of the day, it's making highly educated guesses based on the inputs you give it. You are still the expert. You're the one who understands the business context behind the data.
So, what are you actually looking for in that script? First, check the segmentation. Is it distributing data based on a key that makes sense for your big joins? Second, and this is a big one, look at the sort order. The columns in the order by clause should line up with the filters in your most common, heaviest queries. Remember the phone book analogy. If it's sorted by last name, you can find Smith instantly. If it's not, you have to read every page. It's the same idea. And finally, check the encoding. Did it make a simple mistake like applying run-length encoding to a column that has millions of unique values? A quick sanity check can save you a world of hurt down the road.
So, to wrap it all up, the best way to think about the database designer is as your expert co-pilot. It handles all the complex math, it navigates the tricky trade-offs of that iron triangle, and it lets you reach peak performance way more easily than you could on your own. But always remember, you are still the pilot making the final call.
And that kind of leaves us with one final thought to chew on. As these automated tools get even smarter and more autonomous, how do you think the role of the database expert, the DBA, the data engineer, is going to evolve? Are we moving away from manual tuning and more towards strategic oversight and really deeply understanding the business context? It's definitely something to think about. Thanks so much for watching.